So we're onto the hardware of the rcSurfer, most of which now I reckon could be purchased in the shop. Your drive shafts, your stuffing tubes, your motor drive shaft connector. I'm fortunate enough to have a nice little lathe, a few basic shaping and grinding machines, grinder, drill press. With the help of the lathe especially, I'm able to make a lot of my components, which for me is fun, maybe also more affordable, and then also maybe a touch more accurate and customized to do the job. So let's get along and do it. So for starters, what we're going to make is a stuffing tube. My stuffing tube is made out of a stainless steel portion. This portion gets bonded into the board, so we want it to be strong and hard and have the longevity. Then we have a brass tube with a small bearing tube inserted on the end here, about 25 millimeters long. You'll see in the video as I make it that is actually soldered in place. And on the back end here we have a traditional brass bush. This has been used in model boating for many years, although you'll find in model boating most guys will drill a whole lot of holes in here just to have less resistance for high speed. But in our case, the holes I feel will be a bit of a problem, because that'll perhaps create a little trap for sand with the grease mixed in here, and we're looking for more of a seal than we are the least friction. So I keep my brass bush in one piece. You'll see in the video how I flare the end of this little tube, and that's simply if you look inside this stainless steel housing, you'll see I've set the brass tube inside back about 1 millimeter, so that when this slides in, push it in, you can see it's actually flush in the front there. And our stainless steel drive shaft now floats between a bush at the back here and a bush in the front here, with a bit more volume in the center of the brass tube here to carry stock of grease and to keep a good seal and lubrication. So that's our stuffing tube. Right, so our next component we're going to manufacture is our motor drive shaft coupling. Very simple aluminium connector, 30 millimeters long, 10 millimeters in diameter. Got grub screws to locate it onto the motor shaft, and grub screws to locate it onto the 4 millimeter drive shaft. And what I found, although I was able to purchase these, is that often I would fit them and find that the alignment from the motor side to the drive shaft side wasn't absolutely true, so I'd get a bit of a wobble and a vibration in my setup. And running a direct solid shaft, it's very critical that you have as true alignment as possible between the motor drive shaft and the output drive shaft. So what I do when I manufacture this is drill from one end. I don't move this, I drill from one end through with the drive shaft diameter of the motor, which is 1/8, I think it's 3.17 millimeters, and then I come in with a 4 mil halfway through here, and that seems to help make this as true a drive shaft coupling as possible. So let's go ahead and make that. Right, next on the bottom end of our drive shaft, we've got our 4mm drive shaft, which is machined down to 1/8, which is 317 millimeters, to fit most of the common props for this size, with a 3mm thread on the end. So what we're going to be making for this dry shaft is our little aluminium dog drive. I have purchased a few and used a few, but what I've found with the ones that I've used is that they seem to be made of an aluminium that is very porous, almost like a cast in a way. And after a few sessions, I found the little ears of the dog drive breaking off and my prop spinning free. So I've just now resorted to manufacturing this out of a 304 or 306 aluminium, and they seem to last a lot longer. So this is the little assembly with the prop, a little 3mm nylock on a 4mm drive shaft, and yeah, it seems to be working well. So let's see how we do it. Right, now that we got the drive shaft assembly complete, it's time to focus on some of the flat aluminium fabrication. You'll see a couple of aluminium components lying around here, all of which have been CNC laser cut. It makes life a lot easier for me. It's a lot more accurate, and I'd even dare to say a lot neater. The motor mount plate, we're going to leave. The battery platform we're going to leave for fabrication when we actually install that into the pod. For now we're going to focus on the servo tray assembly and then the bifin assembly. So let's get started. Okay, that was simple enough. Our little servo tray assembly just fits this servo snug, fastens it down, easy quick installation, removal, it can be popped into the board. Okay, so we're now onto the bifin. Right, and there we have our bifin, lever, torque tally, ready to be installed. Okay, so we got the drive shafts done, we got the aluminium fabrication done. Now we're going to move on to the last of it, which is the brass tubing. Over here we've got the brass tubes with the nylon liner stainless steel push rods for the servo to steering arm of the rudder. And then over here we got the water cooling pipes, one inlet, one outlet. This is obviously for two boards, so I'm going to show you how to anneal those and how to bend those. So let's get started. The water cooling tubes. I like to cut the water cooling tube with a proper little tube cutter. Reason being is if you had to cut this tube with a Dremel or a little hacksaw or of sorts and have a very square sharp edge, that edge when you put your silicon pipe over will necessarily end up cutting through the silicon pipe, whereas if you use a tube cutter it puts a natural little comfortable bevel sort of round on the edge of that pipe, and when you slide your silicon tube over here it's not going to stand a chance of actually damaging that tube. So keep that edge down, keep the square edges up, and let's just anneal it quickly before we bend it. We don't want it cherry hot, just want it like a khaki color. That'll be absolutely fine. And while that's cooling down, Just show you, this is going to be our push rod installation for our, from the servo to the rudder arm. Brass tube lined with a plastic type nylon liner, and then we have a 1.5mm stainless steel push rod here. I've got a cool little tool here, it's called a Z press, and you see what happens when I just put this on the end here and crimp it. I'll take it off. I have the Z there ready for to fit onto my rudder arm, but I'll show you more of that when we actually do the installation. So that's the hardware for the rudder control arm. While the brass tubes are cooling down, I think out of all the tools I've ever used in my hobby sport, this little pipe bender, can't tell you how many thousands of bends it's done for me perfectly, and it's definitely a tool worth investing in. Dubro is the manufacturer. Go online, get yourself one. You can try all different kinds of ways, but if you don't get a decent bend in your pipe, you're going to restrict the water flow and you're not going to cool your system adequately. To form the bend, we just slip the pipe inside our pipe bender. I've got some markings that I like to keep an adequate length, so our tube's in there. Just take it a gradual, bend it through 90 degrees. Voila, you have a great little bend. Okay, so there we have our 4 bends, as easy as A, B, C, D, and now we're just going to cut our bevels on them. Remember, we're going to have 1 inlet and 1 outlet pipe, so we're going to have a 45-degree chamfer on the front side of 2 of the bends, because we're doing 2 boards here, and we're going to have the 45-degree chamfer on the back side of 2 of the bends. Right, so there we have it. You don't want to have your angle too sort of far back here, because you'll just have a weak pipe and it'll more than likely break off. About a 45-degree chamfer is perfect. Plenty of inlet. You want to have about, we're going to have about 10mm exposed from the bottom of the hull, and that's our little bend.
There we have our hardware manufactured and ready to be installed into the Aussie Peppers.